All right, now let's start to really appreciate the power of these trigonometric ratios. So here's a question I want us to look at. I want us to look at this right triangle. We're given that this angle is 35 degrees. We're given that the length of RQ is 7.3 inches. And our mission is to find this length right here. Well, Pythagorean theorem is not going to help us here because we need the length of two sides in order to find a third side. Here I'm missing that. But instead, I know this angle measure. So I can figure out a particular trigonometric ratio to use. Now, what would it be? Well, I want to find this. This is the mysterious side. And that's the adjacent side to this angle. And I know the opposite side. So I need to think of something that has opposite and adjacent. Well, that's tangent. So this leads me to the following. To consider the tangent of 35 degrees. And what does it equal? It equals opposite 7.3 divided by adjacent, which is the length we want, PQ. Well, this is great because I can actually figure out now what PQ is. If I solve this for PQ, you can multiply both sides by PQ if you want, and then divide through by tangent of 35. I see that PQ equals 7.3 divided by the tangent of 35 degrees. And now we can see, now we use a calculator. See, now we're not going to kill ourselves here, but we're going to say 7.3 divided by tan of 35, and then there's the answer. I'm going to round this, actually, to the nearest 100th, and I'm going to see 10.43. What are my units? My units are inches. And so this has a length of 10.43. Kind of looks like it's a little bit longer, but again, the figure could be deceiving. This is the actual answer. This is the actual answer. So look how we were able to actually use the tangent to actually find a length of something that was mysterious before. Let's try another example together. So here's a different triangle, triangle ABC. And I'm told it's a right triangle. I'm told this is 66 degrees outside, and this hypotenuse is 5.7 centimeters. You can see that this is definitely not accurate because that's really, really long, but it's okay. This is just trying to give us an artist's rendition, so we have to understand that this is actually 5.7 centimeters. No problem. Okay, so what do I need to do? Well, I'm asked to find, in this question, the length of AB. So I want to find this length. So how do I hook this length up to this angle? Well, that's the adjacent side, the adjacent leg, and I know the hypotenuse. So I need adjacent hypotenuse, cosine. So cosine of 66 degrees is going to be equal to adjacent leg, which is AB, divided by the hypotenuse, which is 5.7. Well, now I can solve this for the length AB by just multiplying everything through by 5.7, and so I see the length AB is equal to 5.7 times the cosine of 66 degrees. So again, I can just type this in on a calculator and approximate it and see that it's 2.32. What are the units? Centimeters. Again, this picture looks pretty good because this is a lot smaller, kind of almost on that order, like, half-ish, right? Kind of close to being half. And so this looks good. Anyway, the exact answer, if we round, is 2.32 centimeters. Look at the power of these great trig things. Let's try one last one. I know you want more, but I'm cutting you off. Here I want to find the length of the hypotenuse, which is YZ, and we're given that it's a right triangle. I'm given that this leg here has length 3.7 centimeters, and I'm given that this angle is 49 degrees. What are we going to do here? Well, let's see. I know the opposite side with respect to this known angle, and I want to find the hypotenuse. Opposite hypotenuse, opposite hypotenuse. Sine. So sine of 49 degrees is going to equal the opposite, 3.7, divided by the hypotenuse, which is that length, YZ. So I can solve this for that length. I can multiply both sides by YZ, and then divide through both sides by sine of 49 degrees, and I see that YZ equals 3.7 divided by the sine of 49 degrees. And if you plug that in on a calculator and round, we see 4.90. So 4.90, and what are the units? The units are centimeters. And so I see 4.90. And so this length here is 4.90. Very, very cool. You can see you're beginning to, I hope, appreciate with me the power of these ratios. They allow us to actually compute things for real. And that's pretty cool.